Hello there and welcome back to Hydroponics Daily, your go-to podcast for everything soilless cultivation. I'm your host, Dr. Russell Sharp, the founder of Utrema Limited. We make fertilizers, biostimulants and biopesticides, all completely unique, and you won't find them, the chemistry, anywhere else. On a previous episode, I talked about Dosatrons and talked about how they can dose a correct amount of fertilizer into a certain amount of water in your stream, through your pipe, and direct to your plants. So using a Dosatron, it takes liquid from a fertilizer container or from a tank, and then doses it into the water stream that's going to the plants to produce a fertigation solution. Obviously, they're only used on run-to-waste systems, large run-to-waste systems. Otherwise, it's not worth having a Dosatron. So medium scale greenhouse upwards. And it's run to waste because if it was circled back, it would just continually be adding fertilizer. So obviously the alternative to that in a recirculatory system is just having a fertigation tank that you would add the fertilizer to as a set amount. And then you would maybe monitor pH up and pH down and other aspects of that and add other nutrients to it. But there are other options if you have a run to waste system. Run to waste can mean just adding it goes out of the pots and into the soil afterwards. So it's not as bad as it sounds, but it still is leaking into the environment. There are a few alternatives. So I just wanted to talk about alternatives to Dosatrons. There is something called a Venturi injector. Now that's not a trade name. It relies on the Venturi effect, where injectors use a pressure differential created by water flowing through a constricted section of pipe, and this pressure drop draws fertilizer or chemical concentrate into the irrigation line. A lot cheaper than Dosatrons, no moving parts unlike Dosatrons. Just like Dosatrons, no power is required. Very simple to install, can be used inline, doesn't require sort of attaching to walls or anything like that, like a Dosatron. But the injection rate varies with flow and crucially pressure, whereas that doesn't with a Dosatron. It's also less accurate and not as repeatable as a Dosatron. So if you've got, unless you're really, really, struggling for budget, then I would stick with a Dosatron type. There is electric meter pumps. So you could have a pump that adds it to the solution. There could be a diaphragm pump or a peristaltic pump, so that could be run by electrics or air pressure, those sorts of pumps, and you could have an air compressor. What are the advantages of an electric pump versus a Dosatron? Obviously, you're going to need an electrical supply, and it's probably going to need to be linked up to the computer, but it provides flexibility in dosing both the fertilizer and any pH or anything like that. So you can vary the flow rate using sensors or at a whim remotely as well. So, and then potentially more accurate as well when properly calibrated, but requires that electrical power, a lot more complex system. So this is not a medium scale hydroponic system. This is a very large scale system and typically a higher life cycle cost and susceptible to damage, corrosive chemicals if materials are mismatched as well. When you're choosing the right pump, you have to be really careful about what materials you can use. And then obviously the technical term for a Dosatron is a hydraulic proportional injector, which doesn't roll off the tongue, hence the way people just chose the leading brand to call them. But you can buy non-Dosatron brands like Mixrite, Injector Meter, Amiad injectors. And so you could choose a non-Dosatron branded one. And as I say, they're water-driven pistons and they proportionally inject concentrate based on the water volume passing through them, not the pressure. No electricity required, just like a normal Dosatron. What are the drawbacks, though, of using a non-branded Dosatron injector? Well, the potential for lower build quality and longevity. So you could be, that's something you have to weigh up. Maybe get experience from people who've used them and compared them to Dosatrons in the past. Look at Reddit and other forums to see where they've used it. There's going to be less options available. They're not going to have the range because Dosatron is the leading brand. It's got lots of options for like the chemicals that could go through it. So like the pH up, pH down, might need specific materials and different flow rate, different dosing rates. So they might have less sort of range of, inclusion rates. So 0.5% or 0.1%, the very low end or the very high end. And service and support, less global service, spare parts availability, things like this. Once it goes wrong, can you get a spare part for it if you're buying it off Alibaba, for example? And then obviously the other option is just to use a fertigation tank. Even if you're not using a recirculatory system, you could potentially just feed the water into a fertigation tank, add your nutrients, and then flow out from there. So very low equipment costs compared to a Dosatron, no moving parts, no power required, but neither require power really. But the disadvantage of that is the proportional inconsistent dosing. It's up to the user to dose correctly. And also it's sat there for a long time, so it could grow bacteria, microbial growth, biofilms, things like this. So, anywhere where there's a tank with liquid sitting in it that's water-based, you could get growth. So not really used. So they are some of the options there for alternatives. If you've used any of those, then I'd love to hear your feedback. Especially if you're in run to waste. So these would be particularly common in America in sort of medium-sized greenhouses where it's sort of run to waste systems where you might, these are good systems where you've got one crop that's hydroponic and then you're able to take the spent fertigation solution and apply it to a field crop. That's the ideal situation because then you're not wasting any of that solution. So obviously you don't have the benefits of recirculating the feed. That's the disadvantage of run to waste. The advantage is that it's a lot more simple. So that's why a lot of people use them on medium scale glass house operations. So if I was in a grow room or a vertical farm, I would always be looking at recirculatory systems because you want to be saving that water and saving that fertigation, and you don't want the issues of how to dispose of it as well, because the EPA or the Environment Agency will come down on you hard. Even in the US, UK, especially in Holland, they caught a lot of glass houses that were supposed to be recirculating their system, actually dumping their fertigation solution into the canals, and they catch them all in the winter because the fertigation solution is nice and warm and the canals freeze over and snow gets on them, and then they could just fly over with the drone or a helicopter and see where the ice is melted in the canals and stuff like that. So be careful. People are always watching you. Whatever you're doing, there's always somebody with a nosy neighbour checking out what's going on. All right, that's been Hydroponics Daily for today. If you found this at all useful, please leave us an Apple Podcast review. I know I say it every time, but it's very important. It helps share the show. But if not, just make sure you click follow so you don't miss an episode. And at the very least, check out utrema.co.uk. EUTREMA.co.uk. Fabulous, unique fertilizers, biostimulants, and biopesticides you won't find in anyone else's portfolio. The chemistry is completely different to everyone else's offerings in hydroponics. And in hydroponics, often all that differs is the branding and the badge and the bottle. So, check it out. That's been Hydroponics Daily for today. I'm off to the gym. I'll see you again tomorrow. Goodbye.